Look closely at this time-lapse. This is a microscopic view of fungal hyphae and spores actively branching across a dark surface. Fungal remediation requires a tactical response against a living, spreading biological agent. When operators enter a contaminated space and physically remove compromised building materials, they disturb these colonies. The immediate and primary risk to the worker becomes inhalation. A single breath in an unsecured hot zone pulls in an aerosolized mixture of reproductive spores, fragmented root-like structures called hyphae, and toxic secondary metabolites known as mycotoxins. The distinct musty odor associated with water damage is actually a secondary hazard. Fungi produce microbial volatile organic compounds, or mVOCs, as they grow, off-gassing chemicals that cause headaches, dizziness, and severe nasal irritation. Over time, the human body's reaction to these inhaled agents compounds. Repeated, small-scale exposures trigger severe acute allergic reactions like asthma, while prolonged inhalation of these contaminants leads to chronic systemic respiratory distress. A minor amount of mold on a residential bathroom tile presents a negligible risk to most healthy adults. But when moisture intrusion allows hundreds of square feet of fungal growth to colonize a commercial building, the concentration of airborne pathogens scales exponentially. Attempting to extract that volume of contaminated material using standard construction tactics without precise personal protective equipment and systemic air containment guarantees massive biological exposure. The tactical escalation matrix plots contiguous fungal square footage on the horizontal axis against the required operational response on the vertical. Protocols scale across distinct zones: Level 1 and 2 under 30 square feet, Level 3 up to 100, and Level 4 beyond. These escalating tiers are strictly defined by guidelines from the Environmental Protection Agency and enforced by OSHA's Respiratory Protection and Hazard Communication Standards. At the state level, the Texas Administrative Code, specifically Section 78.12, sets a rigid legal baseline. It dictates exactly when a formal remediation protocol must be enacted, based on the exact size of the affected area. The objective of this escalating response is to equip the technician inside the hot zone with the necessary respiratory defense, while physically isolating that hazard from the surrounding occupants in the building. Executing a legally compliant remediation project requires mapping the precise architectural containment and respiratory defense to the exact coordinates on this matrix. At the base of the matrix are EPA Level 1 and 2 projects. These involve isolated areas of contamination measuring 30 square feet or less, typically affecting only a few ceiling tiles or individual wallboard panels. Texas state regulations tighten this threshold further. Any project affecting 25 contiguous square feet or more legally triggers the requirement for a formal mold remediation protocol and mandatory PPE provision for all workers. The baseline respiratory defense at this level is a NIOSH-approved N95 filtering facepiece respirator, engineered to trap the vast majority of airborne spores before they can enter the respiratory tract. This schematic highlights the supplementary gear for baseline compliance. Operators protect mucous membranes using sealed goggles with no vent holes to prevent particulate entry. This is paired with thick rubber gloves extending to the mid-forearm to fully protect the skin. Because the surface area of the threat is highly limited at this tier, erecting full architectural containment walls is not strictly required. Technicians instead rely on passive dust suppression. By lightly misting the contaminated surfaces with water prior to physical removal, operators weigh down the spores and heavily reduce aerosolization. Following extraction, the environment must be rigorously cleaned using high-efficiency particulate air, or HEPA vacuums, followed by damp wiping with detergent solutions to capture any settled dust. All contaminated porous materials that cannot be salvaged must be sealed inside impermeable plastic bags before leaving the area to prevent cross-contamination. Even at the lowest end of the threat matrix, physical safety relies on disciplined hazard reduction long before any physical barriers are erected. Advancing up the matrix brings us to EPA Level 3, which covers mid to large-scale isolated areas between 30 and 100 square feet. Tearing out multiple panels of colonized wallboard physically ejects millions of spores into the room. This mechanical disruption causes a massive, immediate spike in airborne particulate dispersion. This diagram illustrates the necessary upgrade in respiratory defense. An N95 mask struggles to process this volume of material over long durations. Operators transition to a half-face, dual-cartridge air-purifying respirator, utilizing heavy-duty P100 particulate filters. Because of the increased airborne load, passive suppression is no longer sufficient. The first layer of active architectural containment requires completely sealing all ventilation ducts and grills within the work zone. Technicians construct physical barriers using secured plastic sheeting, isolating the work area and adjacent surfaces to prevent debris from migrating into clean corridors. Any adjacent spaces must be vacated of highly sensitive populations, specifically vulnerable infants, the clinically immunocompromised, and individuals with existing lung diseases. As the physical manipulation of contaminated architecture increases, operational tactics transition entirely from passive suppression into active environmental isolation. The most intensive tier of the operational matrix is EPA Level 4. This tier addresses severe, large-scale contamination events exceeding 100 square feet. This wireframe displays complete isolation, a sealed work zone with airlocks and a decontamination room. A negative air machine pulls clean air through the airlock, scrubs it, and exhausts outside. This creates negative pressurization. If a tear occurs, clean air rushes inward, containing the hazard. Inside this sealed environment, operators require the most protective respiratory loadout, full facepiece respirators, or battery-operated powered air-purifying respirators to manage the extreme particulate density. But biological matter is not the only hazard present. To neutralize any remaining growth on structural surfaces, technicians deploy chemical biocides, like chlorine or ammonia, which off-gas heavily within the airtight containment. To defend against these fumes, technicians modify their breathing apparatus, adding an organic vapor or acid gas cartridge directly beneath their P100 particulate filter. In maximum deployment zones, operators are simultaneously filtering a massive biological source load while protecting their respiratory systems from the aggressive chemical agents deployed to neutralize it. Scrubbing a surface until it looks visibly clean does not mean the remediation is over. The absolute prerequisite for declaring a space safe is correcting the underlying moisture intrusion. If water remains, the biology returns. Once the area is dry and visible growth is removed, an independent state-licensed mold assessment consultant conducts a strict post-remediation evaluation. The consultant validates the environment using a triad of clearance metrics, a rigorous visual inspection, procedural verification of the work plan, and analytical air sampling to prove the indoor spore counts have returned to the ambient outdoor baseline. This highlights the matrix's core philosophy. PPE protects the worker inside the hot zone, while systemic negative pressure containment protects the surrounding public environment. Disciplined adherence to OSHA respiratory standards, NIOSH equipment ratings, and state regulations is the only way to deliver an indoor environment that is both legally compliant and biologically secure.